All right, so we had a very technical talk. So now I'll start with the second talk, which is understanding MEVs. So it'll be like a bit of finance side of blockchain oriented talk, but just a disclaimer, I've had to learn all about these stuff. I'm also a very technical guy, so bear with me. We'll get to what is MEV in a second, but first, like an intro of what's the background for that. So even in normal markets, as well in blockchain markets, there are opportunities for extracting additional profits by making transactions based on behavior of other users. And some of these opportunities are like perfectly normal thing and perfectly valid, and some of these kind of take advantage of the users. And since blockchain is a very different space at traditional markets, there are some very different opportunities for this stuff that would be like illegal or impossible on normal markets. So first, let's look at how you could extract value based on some things in the market in the normal currency market. So first of all, there is arbitrage. So basically, like if you look at a formal definition, it's like taking advantage of a price difference in two or more markets. So arbitrage is like a perfectly normal thing, and it makes market more efficient because it eliminates price differences between markets, and it's usually perfectly legal. So arbitrage could look like this in a very high-level overview. So there is I don't know, New York Stock Exchange where some stock one sells for $185, and there is market two when the same asset sells for $190. So we could buy the asset on one market and then sell it at the other, have $5 profits, the prices equalize between markets, that's a good thing. So opportunity for that exists on the blockchain. But this is like a very basic thing, so that's already happening on markets. So there is also a thing called front running. So front running is making trades based on private information about future transactions. And in standard markets, it's absolutely illegal. So if you look at basically the same example, on the standard market, there has to be somebody that facilitates these transactions. So usually there is a broker. So as we know that if the user, also in a very high level overview, if the user buys the stock from the market one and sells it somewhere, the price will change. So broker knows that this price will change. So what the broker can do is they can, knowing that the user is making this very expensive trade, they can buy some assets for the lowest price first, then let the user make their trade so that price changes, and then they can sell and have a higher profit than the user. And it is completely illegal in most standard markets. But as we will see in a moment, it's happening in a blockchain, and there is no regulations, and the transactions are public, so why not act upon this knowledge? So, actually, I show you the old version of these slides. Never mind. What is MEV? So MEV used to refer to the Miner Extractable Value. But the opportunities for extracting MEV also exist in the proof-of-stake markets like Ethereum. So the name was changed to Maximal Extractable Value. But basically, what MEV refers to is the maximal profit that can be extracted from the block in addition to normal block rewards. Because for most often in the proof-of-stake or proof-of-work blockchains, there are some rewards for producing blocks that the miners or validators get. But also, you can do some additional things to get an extra money from the block. So in case of Ethereum, there is a concept called mempool. So transactions are submitted there, and they are visible to all network participants. So if you send a transaction, of course, eventually it will be submitted to a block. But for it to be submitted to a block, you have to show to all the people in the network the transaction you want to make, so they can actually take it and include it in the block. But there is a problem with that. If you put your transaction in a mempool, and usually it's a requirement to have your transaction included in the blockchain to put it there, everybody can see what you want to do. And it opens opportunities for kinds of front running that wouldn't be possible in normal markets, and it opens them to basically everyone on the chain. So there are many kinds of extracting MEVs and many ways to do so. And I guess the simplest way to understand how extracting MEV works is a sandwich attack. So bots or just users of the network can see your trade that buys an asset, but they can wrap your trade in their own trades, creating a transaction bundle which results in a profit to them. So for example, if we look at this, assume ETH is priced like $2,200 per one ETH, and there's one user that is making a very big trade for 2,000 ETH. So whatever they want to do with that, but they are making this trade. So they have to submit this transaction to mempool, and now everyone knows that this transaction will be executed eventually. And this is a huge transaction. 2,000 ETH is a lot, and it has to influence the price. So I've overblown the differences in prices a little bit to showcase it, but basically what bot could do is that they see that you want to buy 2,000 ETH, so they can insert a transaction to buy a little bit of ETH at the lower price, let you do your own transaction at a little higher price because they influenced it, and then sell the ETH at an even higher price because your transaction influenced the price of the asset. So they just take your transaction and bundle it in their two own transactions, submit the whole bundle to the mempool, the block validators take that, executes that, and you end up losing some money because you pay more for the asset, or you get less of some asset for the same price, and the bot results in profit because now for this example, with overblown prices, you lost 2,000 USDC because the price increased, and the bot got 20 USDC for basically nothing, submitting the transaction, minus the gas fees. So that's a sandwich attack. And it's happening. What it means to the users is that there is an invisible fee introduced to the trade, because bots like this already exist, and they make lots of these trades. So usually, your transactions end up getting wrapped in this. And also, it increases network congestion, but we'll get into that in a minute. So there's also a concept called bidding wars that is related to MEVs. So if I can make a bot that wraps your transactions in their own transactions to extract profit, everyone can do that, right? So there's incentive to everyone to make these bots. So if bot submits a transaction, like I showcased before, a bundle of transactions to extract some MEV, and the other bot sees that there is also an opportunity to extract MEV, they can submit the same transaction. But what they do is they increase the gas price they are willing to pay. So what the first bot is going to do is then they are going to resubmit the transaction with even higher gas fees. And this ends up in a bidding war or a bot auction. There are different terms for that, but basically bots will resubmit the same transactions with higher and higher gas prices until eventually one of these gets included. And what's end up happening to all users is that the base gas price in the block is increased. So everyone pays more and bots just extract the value. Validators or miners benefit from that because they get more from the fees from the block, but for the end users, it's just more congestion in the network and higher gas prices. So it's not good. But these were all monitoring specific trades and sandwiching them in some transactions. But there are also something like generalized front running. So there are bots that monitor transactions, not just the trades on specific DEXs or whatever, but all transactions. Replace the addresses in the transactions with their own addresses, simulate this transaction, and see if they get any profit from that. And if they do, they resubmit your transactions, but with their addresses replaced and with a higher gas fee, so they basically snitch your transaction from you. And that sounds like a very weird concept, but it's happening. So there is an article called Ethereum is a Dark Forest. I recommend reading that. It's a very short article, but it explains the concept in depth. But there was it happened in 2020. Some user locked up $12,000 worth of token in Uniswap v2. There was a white hack attempt to restore the tokens that user accidentally locked in the transaction. So the guys prepared the transaction that would unlock these tokens from the Uniswap contract and send it back to the user. But what ended up happening is that the generalized front-running bot snitched the transaction before they managed to get it executed, and the bot got $12,000, and it was lost from the users. So it's actually happening. Yeah. But it was talking only about bots, but they're block validators or miners, and they can also benefit from MEV. So usually, there's like no in case of Ethereum, nobody is enforcing that in the protocol. But how most block validators work is they include transaction based on max fee you are willing to pay. So if you pay more fee, there's a higher chance of your transactions being included from the mempool. But nothing from the protocol enforces that. So why not extract MEV if you're a block validator or block miner? You can do that. Why not? So it's actually happening. So it's even easier and even better for the block validators because they can include their own transactions without paying any fee because they are including their own transactions. But also what they can do is they can reorder transactions, or they can even reorder the whole blocks to extract more value. And this is also problematic. So for example, reordering transactions and sandwich, like if we had a sandwich attack from the previous case, it would have to happen in mempool. So the bot would sandwich the transaction in mempool, submit the bundle, and it would be included in the block. But if you're a block validator and you have like these 3 transactions, and there's opportunity for sandwich attack, what you can do is you can just include your own transactions in the block for free and extract MEV like that. And when there's even more opportunity to, I don't know, there is something happening between transaction 2 and 3 that ends up lowering the asset price, what you can do is you can do this. You can reorder the transactions and extract even more MEV. And there's nothing in the protocol that prevents you from doing that. And that's just reordering transactions within a block. But also there's a concept of reordering blocks, which is like very problematic. Because, for example, if we had a block 1, which had like $10,000 MEV opportunity, and all blocks had like base 100 reward for just creating them. The validator 1, in this case, extracts $10,000 of MEV, creates a block, creates another block, and what an honest normal node would do is they would create a 3rd block on top of these 2 and just get the $100 reward, which is like what we expect to happen in a blockchain. But what's preventing block validator 2 from creating a fork? So they recreate block 1, take the MEV to themselves, they create block 2 on top of that, and then they submit their own block on top of these blocks. So now they have the longest chain. So basically there is an incentive to other nodes to now start treating the block like the validators to chain as a valid one. And also, there's nothing in the protocol that prevents you from doing that. And if you convince enough nodes to like believe your chain is valid, they will include that. So this is like very problematic because it causes consensus instability, and the blockchain has to reorganize. All the nodes have to reorganize their blockchains. So this is just plain not good for the users. But for the validators, like they got their $10,000 in MEV, so it's good. So these are like kinds of MEVs attacks. So what are the consequences of these? So you could argue there are some advantages of the MEV. So obviously, these bots do something like arbitrage, and arbitrage is normal in healthy markets. So it increases their efficiency. So that's good. And also there is an incentive to validators to create blocks, because as we've showcased before, there can be a case where the MEV from the block is much higher than whatever the rewards are. So the block creators are incentivized to create the blocks. But from what I've looked, for the end users, these are basically only advantages that exist. But for the disadvantages of the MEV, for the user have more expensive trades. The network congestion is higher, and the gas prices are higher for everyone. And there are also block reorganization and breaks of consensus, which are no good. So it's not all that bad because actually there are ways of preventing MEV. So I've looked, and there are lots of protocols that like allow users to prevent having MEV extracted from the trades in very complicated manners. But basically, like what is the simplest concept, I think, what you can do is you can like have a private mempools where you submit your transactions in a private manner and settle with the block creator. So you pay them something and they include your transaction, skipping the whole mempool. So having MEV extracted from your trades, avoiding having MEV extracted from your trades is possible, but if you are just using network without considering these things, you are probably losing money to some extent. I won't go through all the ways of preventing MEVs because these protocols are just complicated. But I just want to talk about one other risk of MEV happening. So in case of Ethereum. So becoming Ethereum validator is costly. So I think you have to stake 32 ETH to become a solo validator, which is, I don't know how much, but a lot of money. 200,000 zloty or something like that. I'm not up to date with the prices, but it's a lot of money. So you can join staking pools instead. And larger pools have larger opportunities to extract MEVs, so they can earn more rewards for their stakers. So there's incentive for the users to join larger pools. But the problem with user joining larger pools is that eventually what could happen is that all of the consensus in the network could get organized around some couple of large pools, which is not very good for decentralization and not good for the stability of the network. So that's also concerning. But it's just one of the other of the disadvantages of the MEVs. So that's all from me. Are there any questions I maybe can answer?
Do you recommend any bots?
So I haven't really looked in very practical ways of doing that, but if you Google, there are lots of services that do that. I don't want to recommend anything because I haven't used any of these. I only read about MEV, but these exist. So. All right. If we don't have any more questions, I see the pizza has arrived. So thank you for listening to my talk and the talk of Kasper previously. And feel free to stay with us here in the office. So I have some closing remarks I wrote down. So there's a QR code just to the left of me. And if you want to become a speaker of these talks, of these on the future meetups like this, feel free to scan the QR code. There is an application form you can fill out, and we'll reach out to you. So feel free to scan the code, and we're looking forward to all the applications. And thank you for joining us today.